Hello, good morning, everyone. So today we're going over 2.2 graph of functions. Okay, in the beginning, we have to know what is the meaning of a graph of function. So the graph, yes, the graph of functions by, first of all, we're going to learn how to graph the function by using the plotting points. But before I write the general idea, what is the meaning of a graph of the function by using the plotting point? Anyone know what is the meaning of plotting point? Did you hear about this word before? What is the meaning of plotting point or graph by using the plotting point? I think I talked about this before. What is the meaning of plotting point? But anyone remember what I said about the plotting point? Like, what is the meaning of plotting? What is the meaning of points here? Okay, let me remind you. So I mean, for plotting point, we're going to choose like random points, x coordinate. Then we're going to plug it this point inside the function. Then we're going to get the y coordinate. After that, we combine the x coordinate with the y coordinate to get like order pairs. This order pairs, we join these points together until we get like, and we like draw a smooth curve between this point. Then we get the graph of the function. Okay, so here I can say we plot the points like x comma f of x. I mean, of f of x, like we plug the point inside the function. So my x coordinate, it's x. And when we plug it inside the function, I get f of x. So here in the Cartesian plane or in the coordinate plane. So let me just define what is the meaning of x. Here, the x is the input for the function. This x here, I mean, is the input. So here, it is the input of the function. And f of x, this, it is mean the output of the function. Like when I plug the x, I get f of x, the y coordinate of the function. So here's the output. The output of the function. So all my graph, I mean like a graph by using the plotting point, it depending in this. I choose random points, I make a table, choose random points x, I plug it inside the function, then I get the y coordinate. So the x and the y coordinate, they give me like order pairs. This order pairs, this is the points. We join these points like by using a smooth curve, we combine them, then we get the curve. Last time I give you like some types of function. I said we have a function of x. So the types of function here, number one. Let me write it down. Well, number one, we have like some types of function, like a function of the form, a function of the form f of x equal m times x plus b. This is called a linear function. When you see something like that, f of x equal m times x plus b, I mean for m is the slope, and also the b is the y-intercept. So m here is the slope of the function, f of x, and the b is the y-intercept. So it depends. I told you before, if the slope is positive, the curve will be like, look like this, like line like this. If this is my Cartesian plane, the line will be something like this, like that. But if the slope is here, the m is negative, the slope will be, the curve will be something like this, like this. So here I'm going to say m is my slope for this function, is the slope. And this b is the y-intercept. This is the y-intercept. Also, I have like a special kind of function when the slope is 0. When the slope here is 0, the m is equal 0. I'm going to get a function is f of x equal b. F of x equal b, and this function is called the constant function. So second one is the constant function. So second one, number 2 here, the function of the form f of x equal b. This is a constant function. I mean b here, number. Because all the time it's called constant because when I plug any number inside this function, they will give me the same b. Meaning they will give me the same value. All the value is b. I mean that for that, if I want to give you example for this, f of x equal 3 or f of x equal 4. So when I plug any number like 0, they give me 4. When I plug the 1, they will give me 4. And when I plug any negative numbers, they will give me the same number is 4. I mean, like it's called constant function, and the graph of this function is horizontal line. The graph of this function will be like a horizontal line. So a function of the form f of x equal b called is constant function. Number 3, a function of the form f of x equal x to the power n is called the power function, is the power function. Here f of x equal x to the power n is the power function. I'm going to graph some functions in the example below after this. I'll show you what is the mean of the power function, like f of x equals x squared, or f of x equal x to the power 3, or f of x equal x to any positive power like x to the power 4. All this called a power function. Also, I have a root function, a function, number 4, of the form f of x equal x to the x to the power 1/2 is the root function. 1 over n, I mean here, 1 over n. And n must be not equal 0, because if it's 0, they will be undefined. So here, x to the power 1 over n, 1 over n. Make it more correct, 1 over n is the root function. For 3 and 4, I'm going to use it for the example below, how we can graph function with the power. And for 4, I'm going to graph root function too. For number 2 is a constant function, would be look like something like this. It depends on the value of b. So if my Cartesian plane look like this here, this is my Cartesian plane, and b, suppose my b is positive number, like any positive number, like 4, 5, 6, whatever. So the graph would be look like this, horizontal line. A horizontal line, it depending on b. So my b here is positive number greater than 0. So this is my here my b. The b cross the y-axis at this value. For the first one, I spoke about this one is a linear function. If m is positive, the graph will be like this. And if the m is negative, the graph will be something like this. It depends on the value of m. Now let's starting giving example for number 3 and number 4 by using the table and a plotting point. So example, graph the functions by plotting point. So this is the example, a graph the function of by using the plotting point. First function is f of x equal x squared. Second function will be, I'm going to do it here, g of x equal x cubed. And the third function I'm going to do it here is h of x is equal the square root of x. So the first function will be f of x equal x squared. So this is my x squared here. Second one is x to the power 3. Third one is the square root of x. Okay, so first of all, like I said, we have to make the table to graph this kind of function because the question is plotting by using the plotting point. So let me make a small table like this. This is my table here. The x value, the f of x, and this is my third one is the order pairs. Okay, so here's my value is x. This is my x. This is my f of x equal x squared. And this is the order pair x and f of x. Okay, which point would you like to use? Can you give me random points for x? I'm going to choose the 0 first of all, but which point would you like to use after 0? For example, 1, say if he said number 1, what else?
2.
2. Give me negatives. -1, exactly. What else? -2 is good. Now let's starting plugging the point 0 inside the function. F of 0 equal what? What's the value here when I plug the 0? 0, Eric said 0, correct. Because 0 squared is 0. What about the 1? Is 1. Yes, Eric, this is correct. Because 1 squared is 1. What about the 2? Number 2, when I plug the 2? Give me 4, exactly. What about the -1 here? Is 1. Yes, correct. Because -1 squared is 1. What about the -2? Is 4. Yes. Now I'm going to make the order pairs. So starting from the 0 is 0, 0. This is the first point. Second point is -1 and 1, -1, 1. Here is -2, 4. Here is 1 and 1, 1, 1. Here is 2 and 4. 2, the x coordinate this point, and the y coordinate is 4. Now we have to put this point in the Cartesian plane or the coordinate plane. Here's my coordinate plane. It will be a parabola. This is correct. The graph for this function is going to be like something like parabola. I'm going to show you how is the graph of this function. So this is my x-axis. This is my x-axis, and this is my y-axis. So I'm going to choose the point 0. This is my 0 here. This is the point 0. The point 0 and 0. So the first point is 0 and 0. This is the point 0 and 0. Second point is 1 and 1. 1 and 1. So here's my 1 and 1. So this is my 1, the first point. This is the 1. This is 1 here. And this is the 1, 1 and 1. 1 in the x-axis and 1 in the y-axis. So the point will be like something like this. It's gonna be here. Here. Second point is 2 and 4. So the 2 is like around here. This is the 2. And 4, this is 1, this is 2, this is 3, this is 4, like around here. So 2 and 4, it should be something like this. Here's 4, here's 2. So it's gonna be something around this point, this here. So now let's doing this one, -1 and 1. So -1 should be like around here. This is the point -1. And 1, this is my 1 again. So the point should be like, here is the 1, and this is my -1. So the point should be this here in the intersect. Here. I have also -2 and 4. So the -2 is here, and 4 is also up. So it's gonna be like around, this is -2, -4, and the 4 is here. So the point will be here. Now we have to graph like smooth curve between this point. So the curve should be like something like this. This is the curve of this function. This is the curve for this function. Like this, around like that. Here is the point. This is the point here. Close. Close. So it's looked like a parabola, like some students said. It would be a safe. Safe, he said, this is a parabola. This is correct because it's looked like a cup. You see the cup? Any shape of the cup form is called a parabola. So here again, this is 1, this is 2, this is -1, this is -2, this is 1, 2, 3, 4. Okay, any question for the first curve f of x equal x squared? Is it clear how we can graph function like this? Okay, yes. Okay, let's now doing this function, f of x equal x cubed. So the same idea, we're going to make a table like this. The table should be something like that. Here is one. This is my x value. This is my y. Okay. Okay, choose a point. This is first of all my x value. This is my f of x equal x cubed, x to the power 3. Here is my x and f of x. Okay, so again, I'm going to choose like random points starting from 0. This is my 0. And I'm going to use the same points, -1, -2, here -1, -2. Also here, I'm going to use 1 again and 2. Now, what is the value when I plug the 0 inside this function? What is f of 0 when I plug inside the 0? What is the value for 0 when I plug it inside the function?
0.
It's 0, correct? So here is 0. What about the -1 when I plug inside the function?
1.
-1, I mean.
You mean
-1 to the power 3
Oh, it's power 3, yeah, -1.
will be -1. This is correct because -1 times -1 times -1. So -1 times -1 is 1, and 1 times -1 is -1. So the value here is -1. What about -2? -8, this is correct. -8. What about the 1? +1? What's the value when I plug inside the function? Is 1 positive? Yes. And what about the 2? Is 8. This is correct. Now the point will be like 0, 0, 0, 0. And here -1, -1. Here -2, -8. Here is 1 and 1. Here is 2 and 8. So the graph for this function will be something like, so I'm going to graph the Cartesian plane first of all. Okay. First of all, we need the point 0 and 0. So the 0 and 0 would be like the origin point should be here. This is the 0 and 0. Second point is 1 and 1. So the 1, so this is my 1 for the x-axis around here. And here is the 1 for the y-axis. So the point should be here. So here is the 1 and 1, like around here. So this is the 1 and 1. Second point is, a third point is 3, 2 and 8. So 2 in the x-axis, be around here. Around this point, this is my 2. And 8 will be like up. So 1, 2, 3, 4, like be around like here. It's hard to graph it because we don't have like space, but it should be like around up, like here. I'm going to put it here. So choose it here. Is up, close to the 8. The same things for the other side at 1 and 1, at -1 and 1. Here is the -1, and here is the 1. At -1 and -1. Here is the -1, and also here is the -1. So the point should be in the intersect. So this is the 1, and the -1 and the -1. The point should be here. And the other point is -2 and -8. So the -2 this is -2, like around here. And the -8, like it will be like down, but I'm going to graph it around here. A point like down, like here. So the graph actually, it will be, now we're going to graph a smooth curve between this point, these points. So the curve, it should be something like this, going up like that. And then this side would be something like this. So this is like a close for how the graph for the function f of x equal x cubed. Any question? Any question? Okay. Okay, so now for the another function, h of x equal the square root of x. Okay. For the another function, h of x equal the square root of x. So again, I'm going to do the curve, the table, same idea. Here is the table. So again, x value f of x equal x cubed. I mean square root of x, square root of x. And here x comma f of x. Same idea, I'm going to choose random points, plug it inside the function, and then I'm going to graph a curve between these points. So this is here. Okay.
It only has to be positive numbers, right? Positive x values.
Exactly, I cannot plug negative numbers here. Here, I cannot plug any negative numbers inside this function. So in this function, I cannot plug negative numbers. Why? Because it's the square root. The square root, I cannot plug any negative numbers inside this function. So which value would you like to use here?
4. 16, 64.
Exactly. No, I'm going to use like easy numbers like 0. Okay, yeah, go ahead, Shop. 0,
0, 4,
4, 0, 4.
16.
What about 9?
Yes, sorry. 9.
9, okay, and 16, right?
Yes.
So actually, Shop, he chose this point because this point is easy to find the root, the square root of the point. Since the square root of 4 is, we don't have to use the calculator to find the value for this point. So when I plug the 0, the square root of 0 is
0.
0, exactly. And the square root of 4 is
2,
2. Square root
3.
of 9 is 3. And the square root of 16 is 4. Now the point, the order pair is 0, 0, 4, 2, and 9, 3. And the last one is 16, 4. Now again, we have to make, we have to draw the Cartesian plane. Here is my Cartesian plane. So at 0, the value is 0. At 0, the value is 0. Here, some students ask, so basically we can pick the numbers for x. Yes, we pick the numbers for x. But I choose these numbers 0 and 4 and 9 and 16 because it's easy to find the square root of these numbers. Is all these numbers called perfect square. Why perfect square? Because the square root of these numbers, it's known. We don't have to use the calculator. Yes, go ahead, Shop.
So we just chose these numbers because it's easier to show and it's easier to graph. But any number you choose and you take the square root of it, it's going to give you the same shape. So instead of choosing 0, 4, 9, and 16, you could have chosen 1, 2, 3, and 4. But since we don't have a calculator, it's harder to find the square root of it. So just
Exactly.
for here, just choose easier numbers, but no matter what number you choose, the shape is always going to be the same. It's going to be like a little curved out head. Yeah, he's going to show you.
Exactly. This is correct. So here I'm going to start point the distance between the 0 and I'm going to start for the points 4, 0, 4. Here's 8. Here's 12. And here is 16. I'm going to choose this point because I'm going to move this one again. Hold on, it's easy to, 1 second. So I'm going to move this one here a little bit to the left. And the point here, I'm going to choose the 0. The 0. The distance will be 4, 8. Here is 12. Here is 16. And the point here, I'm going to use it like 1, 2, 3, and 4. And also 5 if I need. Now, at the first coordinate here, at first the order pair, the first point is 0, 0. So here is my 0, 0. This is the first point. Second point is 4, 2. So my x value is 4, and the y value is 2. So here, the point should be around here. Third point is 9 and 4. The 9 should be like around, this is 8. The 9 will be like around here. Little bit move to the right about 8, and 8, 9, and 3. So this is 3. So the point should be here. Fourth point is 16 and 4. So this is 16, and there is 4 here. The curve will be like, the point will be here. Now the curve for this should be like from 0 goes up like that. This is the curve for this function. Okay, any question for this example? So this is like the power function, root function. Root function, power, and power function. And this is the graph for any function of this form. Now, graphing piecewise function. So the similar idea for the function like this. Now, this now graphing piecewise function. Graphing. It's a function defined with 2 rules. Function. Okay, so example for this, I'm going to start talking about this functions by example. Example, graph the piecewise function defining below. So the function is defined as f of x make a little bit space up. So f of x equal x squared and 2x plus 1. Here, when the x is smaller than or equal 1. Here, when x is greater than 1. So for graphing function like this, we're starting graphing the first function, the power function, x squared, but we have to start for the domain. The domain here is x less than 1 or equal. Then after we graph the first part of this function, we're going over the second part of the function. We graph 2x plus 1 when x is greater than 1. Again, let's make a table for the first function, but we have to start for the domain x is less than or equal 1. We should starting from the 1 and choosing point less than 1. Then we have to graph the second function by using the table when x is greater 1. So starting from 1, but the 1 is not inside the domain, we'll make it like open circle. Then we're choosing a point greater than 1. Okay, let's make a small table. So here is x. Here's f of x. The value for x. Here's f of x. And here's the point. This is for the function f of x equal x squared. So here I'm going to write it up. F of x equal x squared when x is less than or equal 1. So here's x, here's f of x equal x squared. This is the point x comma f of x. Okay, so let's starting from the point 1. So we're going starting from the point 1. So this is 1. Then choose any number is less than 1. Can you give me the numbers less than 1?
0, -1.
Exactly. 0, -1, and what else?
-2.
Yes. All these numbers
3.
is yes.
It's going to be like a half parabola, right?
Yeah, half parabola. Yes.
Because less than 1, that's like half of it.
Correct. 1, here 0, -1, -2, and all the points less than 2. So what is the value for 1? What is f of 1?
F of 1 is 1.
Is 1. F of 0?
0.
Back inside the function is 0. The -1 is?
+1.
Minus is +1 again.
And
2 is 4. And so forth. Here the point is 1 and 1, 1, 1. Here's the point is 0, 0. Here is -1, 1. Here is -2, 4. And all the points goes down. Now for the second function, 2x plus 1, f of x equal 2x plus 1 for the domain x greater than 1. So we're going to make another table, same like this one, but for the second function. Here is the x value, f of x, and the order pairs. Okay, so x f of x equal 2x plus 1. And here is the order pair, x comma f of x. Okay, so let me starting from the point, we're going to start from this point is 1. But here inside, close to this one, I have to put star. Mean star,
I don't think you
the
can,
one is not. Yes, go ahead.
I don't think you can include 1.
Yes, the one will not be included. So I put star, this is mean it will be like open circle.
Oh, so you're putting it over, you're going to calculate it still.
Yes, I'm going to calculate it, but I'm not going to include it inside the domain. So it will be like open circle. I'm going to show you when I graph this one. So I have to start from the point 1, but I'm not going to include it, but I have to get the value for 1. Now, give me a point greater than 1.
2, 3.
X greater, exactly 2, 3, 4, and etc. Now, what is the value for 1 when I plug inside the function?
3.
What's the value? Is 3 because 2 times 1 is 2 plus 1 is 3. Yes, 3. So the value here 1, 3. The second point 2. What is the value for 2?
5.
2 times 2 is 4 plus 1 is 5. So 2 and 5. What about the 3? 2 times 3 is 6 plus 1 is 7. So 3 and 7. What about 4? 2 times 4 is 8 plus 1 is 9. So here 4 and 9. And all the points. Now I'm going to graph the both of the functions. So here is my Cartesian plane. I'm going to do it here. Okay, so I'm going to start for the red one. Starting from the red one at 1 is 1. So here is the 1. 1. Here is the point first of all. 1, 2, 3, 4. This is minus 1, minus 2, minus 3. We're not going to use that. Okay, here I have 1, I have 2, I have 3, 4, 5, 6, and 7. And also I'm going to use the 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm going to start for the red one. At 1 is 1. So at 1 is 1 would be, so here. At 1 is 1, so here is the 1. And here is the 1 in the y-axis. So the point should be around this point. This. For the second point is 0, 0. So it should be like this point. For the third point is minus 1 and 1. So this is my minus 1. And this is my 1 again. So the function, the point should be here. And here I have minus 2 and 4. So this is my minus 2. And this is my 4. 1, 2, 3, 4. And etc, like all the points down. So if I want to graph the first function, so the graph will be look like a half of parabola. So the graph should be something like this. Starting from this point is a closed circle, goes down like that, then goes up like this. So this is the graph for the first function. This is the graph for the first function. F of x equal x squared when x is less than or equal 1. Now let's doing the second function. At 1 is 3.
Open circle.
Go ahead. What's your question?
Isn't the points, the 1 and 1 point supposed to be open circle?
At 1 and 1 here should be closed circle. Why? Because the equal, you see the equal?
Oh, I didn't
X,
okay.
yes, x is less than or equal. This is mean it should be closed circle. Okay. But for the second one, x is greater than 1. So x greater than 1 will not be included. So this is mean we should be open circle. At 1 and 3 should be open circle. So here is the 1 and here is the 3. 1, 2, 3. This is the point. So the point here should be like open circle, like this. Like this. Here is the open circle. Why? Because I have star and this is not included.
You were teaching us this Sunday, teaching us
Okay, for the second point.
on culture.
For the second point is 2 and 5. Here is 2. Here is 2 and here is 5. So it should be like this. For the third one is 3 and 7. Here is the 3 and here is 7. So this is the point. Fourth point is 4 and 9. Here is 4 and here is 9. And etc. for all points. So the graph for this function, because it's look like a linear line, should be like this. Something like this. And this is the graph for this piecewise function. Any question?
Do we have to label the lines or with the equation?
Yes. Here is the function. We should write here, this is the name of this function. Or we have to label the name for this function. So this is like f of x equal 2x. Let me write it down. Here, f of x equal 2x plus 1. And the red one, we should write the name for this function is f of x equal x squared. Okay? We don't have to write the domain for the function, just we have to write f of x equal x squared like this. Here we have to also to write down the name for the function here is 1. This is 1. This is 2. This is 2. This is 4, 3. This is 4. This is minus 1. Minus 2. Minus 2. Minus 3. Here is 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. Okay. Any question for this example? Is it clear? Okay, can you give me like 1 minute? I'm going back. Just give me 1 second. I'm going back for. Okay, let's doing another example. So the example is example number 2, graph the function what is the 50? What is the mean of 50 here? Mayasha. Any question? Okay, graph the function f of x equal the absolute value of x. Graph the function f of x equal the absolute value of x. Okay, first of all, what is the definition of this function? How can I define this function?
All values of y, x is always positive, maybe?
What you said again?
I'm not sure, but
yeah,
for all values of y, x is always positive.
Yes. So like, I mean, like this function turning the negative numbers to what?
Positive.
To positive, and make the positive positive. It doesn't change the positive.
Absolute values?
This, yes, the absolute values. The absolute values here, they're turning all negative to positive. I mean, like the absolute value for -5 is 5. The absolute value for -4 is 4. But the absolute value for 4, keep it 4. The absolute value for 0 is 0. So the absolute value, they change the function from negative to positive. This is the goal. Yes, what's your question?
I forgot. What if it's -1 and then
the
absolute value? No. The -1 is outside.
-1 like this?
Yeah, -1 and then absolute value of -1. Yeah.
-1 like this?
Yeah.
So the -1, keep it outside. And the absolute value for -1 is 1 positive. So the answer is -1.
Okay, cool.
Okay. Now, if I want to define this function, the absolute value function is defined as x and minus x. Will be x positive, like inside, if the value is positive or greater than or equal 0. And we have to change it. We have to multiply it by negative if the value is less than 0. For example, I want to take the -4. The -4 is less than 0. So I have to multiply this number by negative outside. So it should be like this. And the value for this is 4 positive. Again, what is the absolute value for -3? So the -3 is less than 0. So I have to multiply this number by negative. So it should be like negative times not -3. And this is equal +3. This is the definition of the absolute value. Yes, go ahead. Yes, what's your question?
So, Professor, so in the questions, is there always going to be domain, or we have to know when the domain is going to be like x is going to be bigger than 0 or something like that? Is there always going to be domain? That's my question.
Yeah, for function. But in the exam, I'm going to give you the function like this. The graph the function f of x equal the absolute value. Then I'm going to give you the function like this to make it easy.
Okay. All right.
I'm going to make it easy. For example, if I give you in the exam, graph the function f of x equal the absolute value for x -1 like this. And also, I'm not going to make it like this. I'm going to define it like this. When x is less than 1, x is like, I change the domain. I have to change the domain. It will be like x is greater than 1 or stuff like this. So I mean, like in the exam, I'm going to define you, I'm going to make it the question more easier. I'm going to give you the function like this of x equal the absolute value for x. And also I'm going to define it like that. The absolute value for x like this. I'm not going to make it like hard question.
Yeah, is that also going to be like on the finals or no?
Yes, also for the finals exam.
Got it.
But some questions I'm going to tell you define it because like we did not talk like a question like this, the absolute value, we never talk about this function before. So I'm going to define it. But some function we talk about, we take like huge or long lecture, talk about how we can define some functions. You should to know about how we can define it. But for the absolute value, I'm going to give you the function like this is given. So now to graph function like that, the absolute value for x equal x when x is greater than 0 and minus x when x is less than 0. So I'm going to make a table again for both of the functions. So the table should be like that. This is the x value. This is the f of x. And this is the order pairs. Again, I'm going to choose random points. Value is greater than 0. So starting from 0 and above. 0, 1, 2, 3. And for the second function, the same things. One. Okay, this is x. This is the absolute value. Again, here's x. Here is the f of x equal the absolute value for x. F of x equal x, I mean. And here is the x, comma. I'm going to use the color for this one. So the color is green, x. F of x equal positive x. Here's x, comma, x, comma, f of x. And for the second table, here's the x, here's the f of x equal minus x, and here is x. Okay, again, we have to choose random points. So the f of x, the first function starting from the 0. So I have to put the first value here is 0. Now, what's the next value? I have to choose it.
1, 2, 3, 4.
Exactly. 1, any number greater than 0. 1, 2, 3, and 4. Okay, now for the second one, what is the value of f of 0? What is f of 0? I have to plug inside this function.
0.
F of 0 is 0. F of 1 is
1.
1. And f of 2 is 2. F of 3 is 3. And f of 4 is 4. Now the points is 0, comma 0, 1, comma 1, 2, comma 2, 3, and 3, and also 4 and 4. For the second function, I have to choose a point less than 0, but I should start from the 0. At 0 is undefined, so I have to put like star. This star means it should be like open circle. Okay, what's the value for 0 when I plug inside the function?
0.
It's minus 0, exactly. So the point is 0, comma 0. Now I have to choose the points less than 0 because it's my domain here, x less than 0. What's the value I have?
1, 2.
Negative 1, negative 2, exactly, negative 3, and negative 4. Now, when I plug in the negative 1, what I get? Negative 1 inside the function is 1, exactly, because negative 1 times negative 1 is 1. And negative 2 is positive 2. Negative 3, when I plug inside the function, is 3. And negative 4 is 4. Now the point is negative 1, comma 1, negative 2, comma 2, and negative 3 is 3, and also negative 4 is 4. Okay, so now we have to graph the Cartesian plane like this, the x and the y Cartesian plane. Okay, what's the value? We're starting from f of x equal x. Now, the first function is here, 0 and 0. So we have to put a point at 0 at 0. This is my 0, 0. But first of all, this is my 0, 1, 2, 3, and 4. Here is 1, minus 1, minus 2, minus 3, and minus 4. Here is 1, 2, 3, and 4, 5, and that's it. Okay, starting from the first point, it's 0 and 0. So the point will be here. 1 and 1. This is 1. Here is the 1 and 1. One and 1. 2 and 2. Here is 2. And here is 2. Should be like around here. So the graph for this function look like this. So this is 2 and 2. 3 and 3 and 3. Here is 3. And this is 3, 2. So the point should be like around here. 4 and 4, same things. This is 4 and this is 4. So the curve will be like around here. So this is the graph for the first function f of x equal x. F of x equal x. Now for the second function, at 0 is 0. It should be like open circle. But because the 0 is including already, we don't have to write the 0 as open circle. Just make it like a close. Or just leave it. Because the 0 and 0 from the first one is closed, so just leave it. Now for the second one is like just put like point like that. At minus 1 and 1 should be here. This is minus 1 and this is 1. So the curve should be like this. This is the point. Here's the point. At minus 2 and 2, minus 2 and 2, again, like this. So actually the curve should be something like that. Again, at minus 3 and 3, the point should be here. At minus 4 and 4, minus 4, and this is 4. Okay, again, it should be like around here. And this is the graph for the second function. So this is the graph for the absolute value function. It's look like this. This is f of x equal minus x. Any question for this example? Any question for this example?
Oh, I have just one question.
Yes, what's your question?
So, why didn't you like put absolute value in the equation over there, like on the table, in the table? So we can just put the domain.
Absolute value in the table, because what do you mean exactly? I start from this function f of x equal x, and in the second function f of x equal minus x. It's like a piecewise function.
Oh, okay, got it. You just put the
piecewise function.
domain.
So I start from the domain. I don't get, yeah, the domain here. So again, this is f of x equal x starting from x greater than or equal 0. So starting from 0, 0, 1, 2, 3, 4, 5. This function, the second function is f of x equal or the absolute value when x minus x for the domain x less than or equal 0. So starting from the 0 goes down, minus 1, minus 2, because the minus 2, 1 is less than 0, minus 2 less than 0, minus 3, minus 4. Then I graph this function, the green one, and I graph this function, the red one, and that's it. Okay, is it clear now?
Yeah.
Okay. Any question? Any question now for this example? Okay, so now let's go to the vertical line test. Now we're going to learn a test. This test, they help me to show if the graph or if the curve is defined to be a function or is not defined to be a function. It's called the vertical line test. Here I get a question. Can you please explain why did you put minus x? Because the function, the absolute value for x is equal x when the value x is greater than 0 and equal minus x when the x is less than 0. So x when x is greater than 0, this is the green one, minus x when x is less than 0. So the question is why I put minus x? Because the absolute value, they change the negative numbers to positive. I mean, for that, the absolute value for minus 4 is 4. How I know that? By applying inside this function. This function said if the number is less than 0, you have to multiply this number by negative. So the minus 4 actually is less than 0. The minus 4 is less than 0. So I have to multiply this number by negative. So actually is equal negative times negative 4. Negative times negative is positive, and the 4 is become the answer becomes positive 4. Another thing, the absolute value for minus 2 is equal by applying this function. The minus 2 here is not greater than 0, is less than 0. Minus 2, it's in the second domain. So I have to multiply this number by negative. See the negative here? So this is mean I have to multiply the negative 2 by negative. So negative times negative 2, and I get positive 2. Positive 2. For the second, another things, if I want to give you like the absolute value for like, for example, 3. The 3 is in the first domain. Here, the 3 is greater than 0. So the function said, if the number is greater than 0, just put the same number. Don't do anything, put the x. So the absolute value for 3 is 3 without doing anything. Same things for the absolute value for 2. The absolute value for 2, the 2 is greater than 0. So I have to use the first domain. So I should to put the number the same exactly without doing anything. It's 2. Okay? This is the absolute value. Now we're going over the vertical line test to check things. To check is the function represent, is the curve represent to be a function? So now the vertical line test. The vertical line test. This is mean like is a curve in the coordinate plane is a graph. Like this test to check any curve, if this curve represents a function or does not represent a function. Okay, so is a curve in the coordinate plane of function if and only if no vertical line intersect the curve
2 times.
more than one. I'm going to explain what does that mean. Is a curve in the coordinate plane is a graph of function if and only if will be this curve represent a function if I check by using the vertical line here, if and only if no vertical line intersect the curve more than once. Like I use the vertical line, this vertical line should cross the curve only at one point. I'm going to explain that by example. So here example, what does that mean? Which of the following satisfy to be a curve, a graph of function? So as we learned before, what is the mean of function? Anyone can remind me what is the mean of function?
Every input has to be with a different output.
Exactly. Every input has to take exactly one output. Every input in the domain should take exactly one output. Like the input does not take two output. Every input takes one output. If this output is different or the same, doesn't matter. But should every input take exactly one output, not two output, not three output, just only one output. So this is this vertical line testing if this curve represents these things or not. Test if this curve, if every input take one output. This is the goal for this line, for this test. So suppose my curve like this, if I have a curve like that here, like this. This is my curve. This is the first graph. And also I have another graph like that. Like this. So to check if the first curve represents a function, I have to use the vertical line test. I mean, I have to graph a vertical line like this. This is my vertical line. Then I have to pass it in this curve. And it should passing the point that like this line should be does not cross the curve more than one. Should not cross the curve more than one. So if I'm taking this curve, the red one, you see the red one. If I'm passing this line on this curve, I see this line across the curve at only one point. For example, if I stop up to here, the curve crossed the line only at this point, for example. if I'm moving in this line like this, I see the line across the curve only at one point like this. Also, if I move to the right, the same things. I see this line, the red line, crossing the curve at only one point, does not crossing the curve more than one point. So this is mean this curve represent to be a function. Is it clear for the first one? Is it clear for the first one? So this curve,
it'll be more clear if you do the second one.
Yes, it should be this line, the red line. See the vertical line? It crossing the curve only at one point. Does not crossing the line, the curve more than one. Okay, let's check the second curve. If I go to this curve, I see like this line, the red line, crossing the curve at 2 points. The first point is this, and the second point is this. The same things, if I move to the right, the same things. I see the vertical line, the red one, crossing the curve at 2 points. This is the first point, and this is my second point. If I go to the right again and again and again, I see the same things. Like the vertical line, the red one, is crossing the curve at 2 points. So this is mean this curve is not representing a function, but this curve, yes, representing a function. So here, yes, I can say yes, it is a graph of function by using, because it passing the vertical line test, or by using the vertical line test. But for the second one, it does not passing the vertical line test. This is mean this curve is not representing a function. Here now is not a graph of function by using, because it's failed by using the vertical line test. It fails by using the vertical line test. Here. Any question? Is it clear how we can check any graph is representing a function or not? Okay, I'm going to give you another example. So just to remind you, I'm going to write here the vertical line test like this, show you the curve across the, and here the line crossing the curve at 2 points. Another example, example number 2. Which is a graph of a function. One, two, three, four. First one, second one. For the second function is like this. Okay, for the first one, does this represent a function, the circle?
No.
Does the circle represent a function?
No, that's like the prime example of not a
It's
function.
not representing. Why? By using, exactly. If I use the vertical line test like this, I see that the line crossing the curve at 2 points. You see, this is mean this curve not representing a function. So the answer is no. So the answer here is no, not representing a function. For the second one here, does this curve represent a function?
Yes.
Yes, it's passing the vertical line test. So the answer, yes, it's representing a function because passing the point at only 1 point, passing the curve at only 1 point. For the third one, yes or no?
Yes, that's a function, yes.
Yes, it is representing a function because the line passing the curve at only 1 point. What about the last one?
No.
No, it's not representing a function because the line passing the curve at 2 or 3, it's look like 4 points, not 2 or 3, it's 4 points. No, it's 3 points, 1, 2, 3. So it's not representing a function. So the answer here is no, it's not representing a function. Okay, the last things in this, the last things here in this section is I'm going to give you like some equations, and you have to know, is this equation representing a function or not? So example, now I'm going to give you equations, not function, and you have to check if this equation representing a function or not. Which equation, the question is, which equations representing a function? Again, let me remind you what is the meaning of function. The function, this is the machine such that every input has only one output. You have to know these things before we starting this part of this section. So the function is a rule, like we said, is a rule such that every input has only one output. This means every input has only one output. Okay. I'm going to give you some equations, and we should to know, is every input has only one output? So the example now, does the equation define a function? Equations below define a function. So for the first one here, number 1, I have the equation y minus x square equal 4. And for the second one is x square plus y square equal 4. Okay, let's doing the first one, and I'm going to give you like, and then we're going to do the second one together. So for the first one, when we solve the equation y minus x square equal 4. First step, we have to make this one in the standard form, y equal, or we have to solve it in terms of y. So what we should to do here to make this equation y equal something?
It's plus x squared on both sides.
Yes, exactly. We have to move this part to this side. We have to move this here, the x squared, to this to here. Y, we have to solve it in terms of y. This means we have to add x squared, add x squared. Then I'm going to get y equal 4 plus x squared. As we see here, every input has one output, right? If I plug the 0 in the equation, they will give me 4. The 0, they will give me what? 4. If I plug the 1 inside the equation, 4 plus 1 is 5. If I plug the 2, 4 squared is 4 plus 4, they give me 8. And the same things for negatives. If I plug negative 1, they will give me 1 squared is 1 plus 4 is 5 again. Negative 2, they will give me 8. Negative 3, same things. 3 squared is 9 plus 4 is 13. So as I see here, every input has only one output. The 0 has 1 output. The 1 has 1 output. The 2 has 1 output. Minus 1 has 1 output. Like every element has 1 output. So this, yes, representing a function. Here I can say.
But I have a question, right? That's only true for. That's only.
Ah, yes, go ahead. Go ahead. What's your question?
So let's say this is only true for 1, 2, 3, only 6 x values. What if later on there's something?
Yes. No, they will give me one value, output one value. If I plug any numbers, any positive numbers, or plug any negative numbers, or plugging the 0, they will give me only one value. So this is representing a function. Make sense? So if I plug any number, this number is positive or negative or anything, will give me only one value. So this is mean, yes, it is representing a function. So this equation, yes, represent a function. Now for the second one, x squared plus y squared equal 4. Who will do the second one now? Who will do the second one? How we can solve it in terms of y, like I said before? Again, this thing is very important. You have to focus on this.
You'll subtract x squared on both sides and then take the square root.
Exactly. So number 2, here number 2, let me do it by in the red color. Number 2, I have x squared plus y squared equal 4. I have to move this part to this side. This is mean I have to subtract the x squared from both sides. Now I get y squared equal 4 minus x squared. Now I have to take what? What I should to do now?
Square root of both sides.
Exactly. Taking the square root for both sides, I get y equal what?
Plus or minus.
Exactly, plus and minus. You don't have to forget the plus and minus. Now, as I see here, every input has 2 output. The first output is positive and the second output is negative. So for example, if I plug the 0, I get 4 minus 0 is 4, and the radical for 4 is 2, but I have positive and negative. So the 0, they give me positive 2, and they give me negative 2.
So you didn't have to like like do different numbers to see. Once you see the plus or minus, you already know that's not a function.
Exactly. When I see plus and negative, this is not representing a function. Now, if I plug the 1, for example, no, I'm not going to. If I plug the 2, because the 2 is easier. So the 0, because they give me positive, negative, 0. But if I plug any number here, such that this number should be like making under the radical what? Positive. Here the numbers, it's supposed to be between -2 and 1. For example, if I plug the 1, they will give me positive square root of 3 and negative square root of 3. And this is mean every input, they give me 2 outputs.
It's another reaction. You know,
and this is not representing, and this is not representing a function. Any question for this one? This is very important. You have to know it. You will see a question like that in the midterm exam. It's exactly similar to this. Is not here. This is not representing a function. This is not representing a function. Is it clear what we said here? Here, Eric, he said, y is positive and negative. When you take the square root, like what we said about this in the first class in this course, when you take the radical, they give you the absolute value. So you have to take the positive and negative for the radical. For the equation, when you take the radical for equation, you should write the positive and negative. Can you repeat why this does not represent a function? Okay. For the second one, x squared plus y squared equal 4. So you have to subtract the x squared from both sides. I get y squared equal 4 minus x squared. Now take the square root for both sides. I get y equal plus and minus. Plus and minus, this is mean they give me 2 output. When I plug the 0 inside this equation, for example, I get 4 minus 0 is 0. And the answer, the radical for 4 is 2. Positive 2 and negative 2. 2 output. For the 1, if I plug the 1 here inside this radical, I get 4 minus 1 is 3. And they'll get 2 value, positive 3, square root of 3, and negative square root of 3. So they give me 2 output. Because they give me 2 output, this is not representing a function. But here they give me only 1 output. So this is representing a function. Any question for this? Okay, we're going to stop up to here today, and have a good day, everyone. See you Thursday. This Thursday, yes. Have a good day.